No sweat. No sweat if you didn't finish that yet. Let's see.
Okay.
Morning, Brooke. Okay, folks, let's see. Let me share my screen again. Okay, so here's the curriculum. We're almost done with this unit. We're going to be finished and testing on it next week. We're doing this one here, translations and transformations. And after this is functional values. We'll get to that on Monday. Functional values is, it should be a good lesson and topic and mastery test to do after doing the one we're doing today, translations and transformations, because it's basically the same as that, but we're looking at like the points and the numbers and not just the graphs themselves. So we'll get to that on Monday. Today we're going to look at this guy, translations and transformations. Before you do yours, I'd like to do some of them together as a group so you can see what it's like. And we'll go over the stretches and the shrinks, the ones at the end. So this should look similar to what you guys did on your worksheet in pairs this week, your digital worksheet. They give you the equation. Suppose f of x is x to the third. So that means we're doing the cubic shape. Find the graph of f of x plus 5. And this is the translation, f of x plus 5. The plus 5 is the important part, right? So just like we've been doing the last few days, guys, look at, let me zoom it in. Make it bigger for everybody. Oh my gosh, everyone's coming at once. Here we go. X plus 5. That's the key thing here. So plus 5 is the plus 5. I'm just going to ask you guys as a group. Go ahead and answer me in the chat if you don't mind. Oh my gosh. All right, I'm going to cut it off at some point. Plus 5. Is that happening inside the parentheses or outside the parentheses? I'm going to break this into steps for us. So inside or outside the parentheses? I see one chat. I should have about 9 of you in there. Let's see what you guys say. You can write it directly to me or to the whole group. No problem either way. Is that plus 5 inside or outside? Because that's going to tell us if we're moving up, down, left, or right. It's our first step every time. Cool. 7 of 7 chats. Is the plus 5 inside or outside? Let me just quickly see what you guys are saying. Inside. Victor says, yee! Awesome, Victor. Inside. Good job. And Victor said inside as well. So thanks, guys. Yeah, the plus 5 is inside. Can anyone remember or can anyone tell me if inside the parentheses, is that horizontal or is that vertical for our translation? Is horizontal inside? Oh, I'm sorry. Is inside the parentheses horizontal or vertical? Horizontal or vertical? Up, down, or left, right? Okay, so Victor and Savannah answered. Thank you both. Check your notes or check your worksheet. It's on that first couple pages of the worksheet, remember? Anaya answered. Tira answered. Thank you both. Everyone check those notes. Inside the parentheses means we're doing horizontal, left, right. Anaya, good job. Thank you. To all of you who answered. Thank you. So that helps us narrow it down, right? It helps us eliminate any of the up, down options. So we're going to click on the graphs here and check them out. So graph 1, I expand that one and see how the blue line is way over to the right? It's the crossing point on the x-axis is right here at 5. Okay, it's between 4 and 6. Right there, it's at 5. So this function, this graph, has been moved 5 to the right. Let's look at graph 2. This one, the blue line, the function is way down. I'm saying down because it starts here right at 0, 0, but it's moved downwards to negative 5. Option 3, the blue line, the graph has been shifted up here to positive 5. And then number 4, we see it way over here at negative 5. So each one of our options, it's at a 5, right? But It's which 5 is important to us. Left 5, down 5, up 5, or so forth. Now, inside the parentheses, good job everyone, means horizontal. So we can eliminate the up down one. So we can eliminate graph 3, we can eliminate graph 2. It's not those because those are vertical. So it has to be either 1 or 4. Here's the tricky thing. And this is what I want you guys to remember and feel it in your bones. Horizontal inside the parentheses is always opposite of what it looks like. So do we want to go 5 to the right? It looks like it's 5 to the right. Or do we want to go 5 to the left because that's opposite of what it looks like? Any takers? You can type it in the chat. Horizontal inside the parentheses, always, always, always opposite of what it looks like. Beautiful. Tatiana, Savannah, Tira, thank you 3 for answering. 5 to the left. Woohoo! Because it's opposite of what it looks like. Intuition, guys and gals and folks, intuition tells us it should be 5 to the right because it's plus 5, for goodness sake, right? Correct? But we always go opposite of what it looks like for horizontals. So anytime the thing is happening in the parentheses, we're going to go opposite. So this one would be graph 4 because it's going 5 to the left.
Huh.
Graph 1, I click on this guy again, this is the one where it goes 5 to the right. Quick reminder, inside the parentheses, it's always horizontal, it's always opposite of what it looks like. Outside the parentheses, it's vertical, and we do it how it looks like at face value. Let's find one like that. We'll look at another horizontal in a second. Okay, here's our next one. Suppose f of x is x squared. That's the bowl shape. That's the parabola shape. So they're all the parabola shape. Find the graph of f of x plus 4. This is the important part. That's the translation. So you all see the plus 4. We see that that is outside of the parentheses. Plus 4 is outside of the parentheses. So that means we're doing horizontal or vertical. Is this going to be a horizontal or is this going to be a vertical? Tell me in the chat. Horizontal or vertical? What do you think? 3, 4 people, or 4 comments at least. It's outside the parentheses, and that should be our first clue. It's going to tell us horizontal or vertical. We have to know. Woo! Tira, vertical since it's outside. Savannah, vertical. Thank you, guys. You're all hearing what I'm dropping. So vertical is outside. Beautiful. So now we can eliminate any of the left-right moves. So number 1, it looks like they're shifting it over to -4 because that's where the bowl shape is. It starts at 0, 0. They're shifting it left 4, so it's not graph 1. And graph 4 is also a horizontal. They shifted it right 4. So we can knock those out. We're not going to choose 1 or 4. It has to be 2 or 3. So graph 2, it looks like it went down 4. 3, it went up 4. Here's the other thing we have to remember. Vertical translations, we do them at face value. We do them how they look on the equation. So f of x plus 4, we're going to literally move it up 4 units. So go ahead and vote. Do you want to pick graph 2 where it went down, or do you want to pick graph 3 where it went up? Go ahead and vote in the chat. Remember, no judgments. I'm not like giving you guys a score or a grade or a judgment of any kind. I just want you to vote. Best guess on what we've been doing. How would you vote here? Graph 2 is down 4 units. Graph 3, up 4 units. All right. I'm going to, at the end of today, I'm going to double check on who's been answering just to give you guys your badges. So high five to all of you who are answering. I really appreciate you participating. And I'm seeing a lot of people saying Graph 3, up 4. High fives. Boom, real high five from far away. It's real because I mean it. Love it. Love doing math with you guys. High five. Okay, cool. Let's try another one where it's inside the parentheses. It's 11:13, so we've got time still. Let's try this guy. No, let's not try that guy. I don't like that guy. Let's try another one. This one. We haven't been doing a lot with the straight line function. So this one, look at these options. These are all straight lines. This is the linear function, just f of x equals x. Now, quick reminder, for the straight line function, just like the other two, its starting place is always at 0, 0. So I hope you guys can see my cursor here, my blue arrow. Right at the origin is where the original parent graph should be. Our translation, though, it's moving like left, right, or up, down. With the straight line, it's a little hard to tell. Is it moving up or is it moving left, right? It's kind of doing both, honestly, but you can still express it using the same rules that we've been doing with our translation. So for this one, the graph, find the graph of f of x plus 2. You look at that and your first question to yourself is it inside or outside? This one is inside the parentheses. So then you go, okay, that means it is horizontal and you're doing opposite of what it looks like. Meaning it's going to move from the origin opposite of plus 2, horizontally. F of x plus 2. Real quick here. The straight line can be a little tricky, even though it's the easiest looking function, right? It's not curved like the other two that we've been using. But because it's a straight line, it's almost kind of hard to tell. Am I going left or right or up or down? So the parent graph goes right through 0, 0. Like this, right there. That's the starting location. Think of it as like beginning or starting right there. So we want to do f of x plus 2. Okay, you see it's inside. Cool. And that means it's horizontal. And we do opposite of what it looks like. So we're going to go negative 2. So I want to drag this spot, negative 2 on horizontal. So over 1, over 2 to the left. So we should see our translation looks something like this. Because the whole purple one, the original, was pushed leftward 2 spaces, including our origin spot. So it should be going through at negative 2 right there. So let's check out our options. Option 1, it's doing what we want it to do. It's going through at negative 2. Option 2 is interesting because it's going through the x-axis at negative 1. So that one looks like it went over 1 and not 2. Interesting. Option 3, it went to the right 2. I'm tracking that x-intercept spot. Instead of 0, 0, it's at plus 2. And then this guy went plus 1. So for this graph, we would want to go with option 1, graph 1, because we see it's crossing through right here at negative 2. So it's our parent graph shoved over left 2, opposite of plus 2.
Josiah, I have a question.
Yes.
So say, for example, if it was like f in parentheses 1x plus 2, would the line move from like the middle or starting place to like left or right?
Because it's it would be 1 times x plus 2. Is that what you mean?
Yeah.
Interesting question. Good. Okay, so technically, no, it wouldn't. And here's why. Because the number you chose was 1. Tell me if I'm hearing this um, correctly or incorrectly. Is that what you're describing?
Yes.
Okay, good. So if you chose any number that exists besides 1, then yes, Tira, it would move. And let's look at that together right now. When this is what I ended yesterday with, was if we're multiplying stuff like that 1 that you picked, that does warp the picture. It warps it and stretches it or compresses it. But 1, because the nature of timesing something by 1 doesn't really change it. For instance, 1 times x is still x. So in this case, this is a special case where it doesn't actually do a change or a warping. It's going to basically keep it as still x plus 2. Let's say instead, though, we multiplied it by something like this, 5x plus 2. Now it's going to warp the picture, and it's not going to be the exact same one we had before. It's still going, this tells us, the plus 2 tells us the whole thing is going to move to, can't spell, to left, negative 2. This tells us it's going to get warped. This is inside, so it's a horizontal warping, and it's opposite of what it looks like. So this is where we left off yesterday. It's going to stretch, it's going to be a horizontal compression of 1/5. The opposite part of doing our compressions or stretches, it's not going to be negative 5. It's going to be the reciprocal of 5. So it's 1 over the number you see being multiplied. So let's do it. You know what? The fast way that I'd like to show this to you guys, let's go to Desmos. So I'm going to go to Desmos and we'll look at a couple examples. And then I want to look at a couple from the mastery test with you. Desmos.com. Again, I would love it if you guys are using Desmos on your own to check your equations, to do some fast graphing. It's not cheating, it's using a tool. So please use it. So let's try, Tira and everybody, I want to back up a second before we do the linear. Let's do a parabola if that's okay, just to see the warping a little more clearly. So let's make f of x equal to x squared. This guy. There's our parent graph. Notice how when I type in x squared, it goes right through 0, 0. That's like our home base, our starting position. Now let's do a warping of this. So let's do f times 5x. And in blue, we see it is now skinnier, moving up 5 times faster than the red one. It's been compressed inward. I can't draw on the screen, unfortunately, but it's been smashed from the sides by a factor of 5. We'll keep that up there. Now, let's see what happens if we put the 5 on the outside. Okay, now it's the green one is our, I'm going to hide blue for a second. Green is still a vertical, but it's being, should be being stretched up by a factor of 5. So over 1. Oh, that's why, because I've got these grid lines here. Let me change this. Where's 5 at? There it is. Right here. Trying to get it right on. There it is, 1 comma 5. So it went over 1, up 5. So it's been stretched upward by a factor of 5. Where our horizontal one, where the 5 is on the inside, This one is over 1/5. 0.2 is 1/5 up 1. And how does that relate to the 5? If I'm all the way up at 5, I can't get it to be exact. So if it's on the outside, you're technically stretching it vertically. If it's on the inside, you're compressing it horizontally. So they don't look the same. My green and my blue are not the same graph, because one is a vertical stretching and the other one is a horizontal compression. Let's see what happens if we do a fraction instead of like a whole number. So I'm going to block these two out. We'll keep red up as our parent graph. Let's do a horizontal with a 1/5 times x. Now look at our purple one. It's just created our transformation. This time it's like a huge bowl shape. It's still a parabola, but it's much wider than our parent graph. So this has been stretched out by a factor of 5, the reciprocal of 1/5. So it's been like pulled over. So if I go to 1, 1 on my parent, right here, that 1, 1 has been pulled this way to 5, 1. Stretched out horizontally, right there, 5, 1. Opposite of what it looks like. Horizontally, it's horizontal because it's inside the parentheses. It's opposite because everything we do inside the parentheses is opposite. So you might think, oh, if I multiply by 1/5, this 1, 1 spot on my parent graph gets like pulled in to 1/5, but no, it gets pushed out times 5 because opposite for whenever we're working with horizontal stuff. Now let's try multiplying 1/5 on the outside. Okay, so in black now, it's still wider, right, than our red parent. Let me get the purple out of there. So, but it's not quite as wide as the purple one. This time it's vertical because it's outside, and we're literally taking all the original points and we're compressing them to 1/5 of the originals. So for reference, here's 1, 1 on the parent. Okay, right about here. Okay, so there's 1, 1 for reference. This location is smashed down right below it to 1/5 of the original height. So over 1, up 1/5, which is saying 0.2. That's the decimal of 1/5. So we're compressing it vertically. The red one is being smashed like a sandwich to become the black one. So this is the tricky thing. We can do stretches and we can do compressions or shrinks. We can do them vertically and we can do them horizontally. They're not the same thing. You might think, oh, well, like horizontally stretching it is like the same thing as vertically, compressing it, but they don't. They're not exactly equal, as we can see here. They make different graphs. So vertically stretching. Again, here's our times 5. So we're vertically stretching the red graph to become the skinnier green one. And here's where we're horizontally stretching to make the purple one, pulling it outwards, starting from red, becoming purple. So here's the good thing. What is consistent for us is that anytime we're working in the parentheses, whether we're multiplying a number or adding or subtracting, This could make some good notes. And this goes along with everything we've done this week. In the parentheses means horizontal, and it means do the opposite. If it's out of the parentheses, it means we're doing something vertical, and we do it exactly as it looks. We do it at face value. And this applies to our translations, moving it left and right, up and down, and it applies to the stretches and compressions. So for doing the opposite above, for horizontals, if it looks like this, x plus 3, this means we actually go left 3, go negative 3. If we were doing a multiplying, like 3 times x in the parentheses, this means we're horizontally stretching it by 1/3, or compressing it by 1/3, I guess I should say. Because 3 times makes us think, oh, it should get bigger, right? We're like pulling it out, but we're actually smashing it, so compressing it, because it's opposite of what it looks like. Compression of 1/3. But for verticals, we do them exactly what they look like. So for verticals, if I had f of x plus 3 on the outside, it means just go up 3. And if it was something being multiplied, like 3 times f of x, and it's on the outside, well, it's taking the original and stretching it upwards 3 times faster than the original. So stretch up by a factor of 3. So this is what's consistent, which I think is helpful, is that in the parentheses, it's always horizontal and it's always opposite. Outside, it's always vertical, and we do it as it looks like, as it should be, like we think about it, instead of any oppositeness. Okay, I'm talking too much. Are there any questions or concerns so far that you've been thinking and you'd like to ask or share? Please.
No.
Let's look at a question from the mastery test using the stretches or compressions. Okay, where is it? So like halfway through, it switches over to doing questions that have the stretches or compression. So basically multiplying will be in it. First half is just moving it up, down, left, right. Here we go. And it's one with a straight line. Okay, so and it's actually both. So let's look at this together. Okay. Here we go. Okay, so here's our instructions. Suppose f of x is x plus 1. Okay, they're kind of mixing it up on us here. Find the graph of f of 1/4 x. Okay, so how is this mixing things up? The original function is not just x or just x squared, it's x plus 1. So that means the original function, our parent graph this time, would be starting at plus 1, like this. Not through the origin, because of this plus 1 in the parent graph. Now, we're going to warp it. We're going to do a stretch or compression based on this rule here. This is saying it's in the parentheses, 1/4 times x. So we see that it's in the parentheses. So that means it's horizontal, and we're going to be doing the opposite of what it looks like. So instead of everything being stretched outwards or smashed inwards 1/4, it's actually going to be times 4. So for example, let's pick this spot here. Pick this spot, this point. Because of the translation 1/4 x, this spot for our translation is going to go out 4 times farther than it is now. So it's going to become, let me change to a different color for our translation. It's going to be out somewhere like this, 4 times farther away. If we pick another spot like this one, it's also out 4 times farther, right here. It's not shifting over, but everything's going to be kind of tilted or stretched by a factor of 4. And then same as on the left negative side. So if we pick this spot here, it's getting pulled out by this factor of 4. So it's kind of being pivoted, stretched by a factor of 4. Opposite of what it looks like it should be 1/4, meaning it gets like shrunken horizontally. But because we do opposites for horizontal, it's getting stretched out by 4. I'm going to hold here for a second if people are writing down or getting a notes of some kind taken. And we'll look at another one just like this one in just a minute. All right, so another one. Here we go. In fact, I'm just going to take another one too while I'm here. We'll do both of them. Okay, so here's 2 more to do. Okay, suppose f of x is, so this is our parent starting, x squared plus 3. It's a little cut off, but it's x squared plus 3. Let's not even look at the translation yet. I don't even want to know what the transformation is supposed to be. Let's graph the parent so we know what that looks like. It's the parabola shape, but it's already been translated plus 3. You see that? So that's like starting from our normal happy starting location right here, but moving the whole thing up 3 units. So here is our actual parent graph at 3 higher. So this is our parent. This is f of x equals x squared plus 3. Now we've got to do the transformation that they gave us at the end. So it is f of 2/3 x. Okay. Remember, inside the parentheses means horizontal and opposite. For multiplying, the opposite is flipping the fraction, the reciprocal. So that means we're going to do horizontal. And because we're going to flip the fraction, it's like multiplying the original red parent graph by 3/2. So this is tricky because it's not a whole number, but 3/2 is not a fraction in between 0 and 1. It's actually bigger than 1. 3 divided by 2 is 1.5. So what's happening is the red function is being stretched outward, getting bigger, 1.5 times bigger. I'm going to change my color to show the transformation. So pick any spot to help visualize this. I pick this spot here, and this is going horizontal. Why is it horizontal? Because our rule was in the parentheses. So horizontally, this spot is going to get 1.5 times, that's 3 halves. It's like taking this location and saying times 3 halves, and it goes out to its new location. And the same is happening on the left. It's going out more negatively, times 3.5. So in purple now, we've got f of 2/3 x. Think of it as like the height of my points that I'm picking to kind of follow this are staying the same. But the xness, the horizontalness of it, is being stretched or compressed by whatever the number is that we need to use, which in this case is 3 halves. Let's look at another one. Oh, this is similar. Good. Okay. So our next question is similar to the last one. Look at the equations. It's x squared plus 3. That's the same starting parent that we used last time. But the transformation is a whole number this time, 2x. So again, I'm going to start with the parent so we can visualize what that should look like. It's the parabola, which we know is like this, but it already has a transformation of plus 3 or translation of plus 3. So here's our parent graph, just like last time. It's the same parent graph as the last example. Why is it there? Because of that plus 3. So it's starting here. But now we've got to do this transformation. The transformation is f of 2 times x. Now, again, I can't stress it enough. What's that times 2 going? Where is that? That's in the parentheses. In the parentheses means it's horizontal, and we have to do opposite of what it looks like. And for multiplying, that means the reciprocal. So it's like taking the original points on the purple parent graph and multiplying all the x numbers by not 2, the opposite is a half, 1/2. Do the opposite. So for us, that's going to be like multiplying by 1/2. So let me change my color to show this. Okay, so if we pick a spot, like this spot right here, that point on the graph, well, the height of it's going to stay the same, but after doing the transformation, the 2x, it's going to be like multiplying it by a half. So instead of being out this far as it is right now, it's going to be half of that. It's a horizontal compression. It looks like it should be getting bigger because it's 2 times x. But doing the opposite means we're going to smash it in by a factor of 2. So all spots get pushed in, something like this. So if you pick another spot, that's already this far away from the x-axis. So instead, it's going to be halfway. So my picture's a little off. It should be like right here. The same rules are applying, but what's different and new for us from yesterday is when we're dealing with the multiplying numbers, it's not a negative for opposite, it's reciprocal for opposite. So like this example, we were given 2x. What we're going to multiply by is a half horizontally, so the whole thing gets skinnier than the original. Let's see if we can find the actual answer for this back on Edmentum. Here's this question. So graph 1. The problem with graph 1, look at where it's like bowl is. It should be up at plus 3. We know that the original parent graph was starting up here at 3. This one is at 1.5. So right there, I think we can stop and move on because it's not even at the right height that we know it should be at. This one is at 3. It's bowl. Remember, because that's where it starts at 0, 0, but we know that it's going to be up 3 because of its parent graph equation. And it's pretty skinny looking, so this is a good contender for our answer. Let's check out the other ones. This option, graph 3, this is all the way up at 6 high, so that's kind of funky. It shouldn't be up there. It should still be at 3. So it's not that one. And for graph 4, this one is at the correct height at 3. However, this is wider than our normal parabola. And we know that doing our transformation of 2x is going to make it skinnier because it was multiplied, all the x numbers were multiplied by 1/2. This looks like they were actually pulled out horizontally, not smashed in horizontally. So we would choose graph 2 here. Okay, it's 11:45. It's of course, as always, I went longer than I want to and mean to. Let's do a chat vote. Wake up, everybody. Let's do a chat vote. You can chat just to me. I'll even stop sharing so people don't see what people are voting for. Would you like to start your mastery test now? And you can ask for help on any questions while you're doing it. Or would you like to do more examples like as a group from the mastery test? Please vote in the chat. We can start the mastery test individually and get help, or we can just continue doing more examples for the next 15 minutes. So far, only 3 people have answered, and there's 10 of you here. I don't want to walk over anybody. I want to do democracy here. So I want to hear what you guys want. Okay, so far, who's all voted? 1, 2, 3, 4, 5. Only 5 of you out of 10 of you had voted. Eesh. Again, this is like what happens in actual politics in America. Not enough people vote. And then we end up with crazy things because not enough people are voting. So I appreciate you who have voted. So far, it looks like it's actually half and half, of course. So let's tally them up. Examples or mastery test? Examples, mastery test, examples, mastery test. You know how we're going to solve this? I just figured it out. Here's what we're going to do for the next 14 minutes. If you want to start your mastery test, do it. Go now. Start now. You can stay on the call. I'd like you to stay on the call. If you want to mute me, that's cool. Go ahead and mute me. I won't ask you for, I won't be calling on people. If you want more examples, I'm going to do more examples with you right now. Okay, let's do both. We'll split the baby. So if you're ready to start your mastery test, I want you to jump in and start it now. If you'd like to do more examples, we're going to do that now. Thanks, everybody, for voting. I guess I should have just thought of that from the beginning, though. Here we go. Let's do some more examples. So I'm going to do more of the harder ones where we're mixing, mixing them like this one was. The transformation and the, translation. Okay. So let's just continue doing more examples. And if you're ready to start your test, I want you to do that. Homework for everybody, just so you know, is to do this mastery test. So if you don't do it right this second, it's cool. You've got all weekend, but I want you to do it before I see you again on Monday. If you don't pass, no judgment. What are we going to do? You're going to redo it. You can come and get help from me on Tuesdays at 3. You can get help from Brandon. We can Always retest. So don't stop if you don't pass the first time. Okay, suppose f of x is x minus 2. What does that look like? Always start by knowing what the parent should look like. X minus 2, this is our linear. And the translation it's starting with is minus 2. There's no parentheses. It's happening, think of it as to the outside. So it's like the linear function, which we know goes like this. But we're starting with that minus 2, so it goes down here vertically. So here's our parent graph. Then we have a transformation, a warping with that 1/2 times f of x. So over here, let's investigate that. 1/2 times f of x. Okay, you see this is outside the parentheses. So that means it's vertical. And you're doing it at face value. So if I multiply half to something, it gets smaller, right? So what's happening here is vertically, every point on the parent is being multiplied by a half. Think of the x's staying where they are, but the y portion, the height of it, is being multiplied by a half. So for example, let's pick a spot right here in purple. So here's a purple point on the original parent graph. But if I were to keep its x where it is, so it's going to be above or below, right? The x stays the same, but the y, the vertical, is being multiplied by a half. Well, halfway between here and the x line is right in the middle. So with linears, it's a little harder to see because the shape is just a straight line, right? But the direction is basically being changed because we are multiplying the entire red line by a half. So it's not getting stretched up, it's being compressed vertically because we're multiplying it by a small number, a half. Let's see if we can find that back on Edmentum. So here they only give us 2 choices. So folks who are with me and doing it, examples, let's look at the 2 options. Option 1, oh, I'm sorry, option 1, wait a second.
Aren't we doing the opposite of x minus 2?
Good question. It's not the opposite because the 1/2 is happening on the outside. So we're doing it face value. But
Okay.
I just realized something, Tira, and I'm embarrassed and I'm sorry that I didn't mention this to you guys. I see something. I made a mistake. What we've been doing is correct. However, when we have the something I didn't apply to the last examples. So 1/2 times f of x. Let me go back to our writing board really quick. All right, my bad. Let's do this. Okay, so for this problem, the one we've been doing, we're multiplying 1/2 times f of x, right? It's on the outside. So if you were to multiply 1/2 times f of x, and you asked about this earlier, Tira, does the function like move when we multiply it? It is moving, and I didn't factor that into my last few examples. If you multiply 1/2 times the function f of x, let's see what happens to all parts of that. 1/2 times f of x is like saying 1/2 times x minus 2. I'm just taking the whole parent function right here, parent, and we're going to multiply a half to it. for this transformation. So I overlooked this. So if we multiply a half times the original, it is doing the warping that I was describing with our purple line. But also, because of that -2, and this is what I overlooked, -2 times a half, well, that simplifies and changes a little bit. So instead of -2, it becomes -1, meaning it's no longer at -2. The warping is happening, so it's got a lower slope than the red graph does. So it is going down, and it's being warped by a half, like we said, but it is also now going through at -1. So that is happening whenever we have more to our parent graph than just like x or x squared or x to the third. And I overlooked that, and I wish I hadn't. So it is going to change the location of its like y-intercept. Because we're doing the warping, the half, and it has that -2. And for the last few examples, how that's going to affect it is that the warping is happening the way we've been describing it, but also the +3 might be changed. So let's examine this last example. This is the one we did previously. What happens if we take the original parent function? I'm going to do that here in red. It's the one they gave us. And see how the transformation is f of 2x? So it's inside the parentheses, and all that stuff applies. What happens if we actually switch out our x's in the parent with 2x from the transformation? This time we're not multiplying 2 on the outside because the transformation is 2 is in the parentheses. It's being replaced wherever we see an x. Like so. So on the top, we've got our parent graph starting, and below we've like applied the transformation. Okay, so this time it's still going to be at +3. See how the +3 is still there. So if that's not being made to 6 or 1.5 or anything, but the horizontal part is happening in there with x. So if we applied this, it's going to be 4x squared plus 3. So technically, this is the new equation if we needed that. And it is going to give us the red graph that I made earlier, because now it's going to still be at +3. So bingo right there. That's good. But it's warping it up by 4. And that's where the opposites are happening. So you put an input in for x, it gets squared, and then it gets multiplied to 4. And that's why the resulting picture or graph of it, it looks skinnier because it's moving up 4 times faster than the original graph was. So it looks like it's going to be vertical multipliers. So back to this example where I realized my error, my mistake, what I overlooked. Because we multiplied vertically, meaning we did it to the whole graph of f of x, it does result in kind of moving its y-intercept. So it moved up to -1 here. So let's look at one more. I know it's basically time for class to be done. I'm going to start one more real quick with this mindset, and then I'll let you guys go for the day. Don't go yet because I want to take down attendance. I guess I should do that now. All right, let me do attendance quick, and I want to do one more after that. Anayan, Anthony, and Brooke. Anthony and Brooke. Woohoo! All right, Savannah is here. Philmon and Levi. Victor was here. Victor, Tira, Xavier, Tatiana. Awesome. And who else did I miss? Anybody? No. Okay, great. Let's do one more from Inventum. Cool. Okay, let's try this one. This will be good. It's another vertical. Why is it vertical? Because of that 2 multiplied to f of x. So let's see what happens here. All right, here we go. Okie dokie. So that's our caveat. That's our like extra special rule. For these vertical transformations, it will affect, it's like +2. It'll affect that starting position. But I still want to start with the parent graph to see what it should start like. Okay, so here's our xy. Parent graph. It's the linear function x +2. So instead of going through at 0, 0, it's going through at 2, high, +2. So here's our parent, like so. Awesome. Now for the transformation of 2 times f of x. I'll do it in purple. All right, so 2f of x, that's outside. Wonderful. That means it's a vertical thing happening. So what's happening is all the original points are the x, think of them as staying the same. So you pick a spot like this one, and now it's moving up times 2 higher than it was before. So instead of being right here, wherever that height is, it's double that. So it's like being pulled up. At the same time, the y-intercept is going to change too, because we're multiplying 2 times the entire function. So my parent graph, f of x is equal to x plus 2. If you multiplied both sides of this by 2, like our transformation is telling us to, then we get the transformation equals 2x plus 4. And that's the important thing that I forgot to mention earlier. So it is moving it up to here at 4. And it is still being stretched vertically by a factor of 2, like this. So it's steeper, and it's got pulled up to 4. Steeper because it's like climbing faster than our original parent red line was. So back in Inventum, they give us 2 choices. Here's one choice, and here's one other choice. So just looking at the steepness, we can see that the steeper one that's moving up 2 times faster is graph 1. And not only that, but its y-intercept is at 4 now. Looking at graph 2, its y-intercept is down at 1. So this is actually a compression vertically, where it's gotten like smashed down. But we want the one where it's been stretched out and gotten taller vertically, steeper vertically. Graph 1. Okay, it's 12:02, so I'm sorry I've kept you guys late. That's it for today. I still want everyone to do your mastery test today.